Welcome to the activity of descriptive statistics, presented by Sakshi Kadam. History of statistics. How do you pronounce it in other languages? Latin word of statistics is status. Italian word of statistics is statistia. German word of statistics is statistic. French word of statistics is statistique. Carl Pearson. The modern field of statistics emerged in the late 19th and early 20th century in three stages. The first wave, at the turn of the century, was led by the work of Francis Galton and Carl Pearson, who transformed statistics into a rigorous mathematical discipline used for analysis, not just in science, but in industry and politics as well. Galton's contributions included introducing the concepts of standard deviation, correlation, regression analysis, and the application of these methods to the study of the variety of human characteristics, height, weight, and eyelash length, among others. Pearson developed the Pearson product moment correlation coefficient, defined as a product moment, the method of moments for the fitting of distributions to samples, and the Pearson distribution, among many other things. John Wilder Tukey. John Wilder Tukey was an American mathematician and statistician, best known for the development of the fast Fourier transform, FFT, algorithm and box plot. The Tukey range test, the Tukey lambda distribution, the Tukey test of additivity, and the Teichmüller-Tukey lemma all bear his name. He is also credited with coining the term bit and the first published use of the word software. Johann Carl Friedrich Gauss. Johann Carl Friedrich Gauss was a German mathematician, geodesist, and physicist who made significant contributions to many fields in mathematics and science. Gauss ranks among history's most influential mathematicians. He is referred to as the Prince of Mathematicians. Gauss' the contribution from Laplace derives the normal distribution, the bell-shaped curve fundamental to the study of variation and error. Nalini Ravishankar. Nalini Ravishankar is an Indian statistician interested in time series analysis and in applications of statistics to actuarial science, business, and transportation. She is a professor of statistics at the University of Connecticut, co-editor-in-chief of International Statistical Review, and president of the International Society for Business and Industrial Statistics for 2015 to 2017. Ravishankar earned a bachelor's degree in statistics in 1981 from Presidency College, Chennai. She completed her PhD in 1987 from the New York University Stern School of Business. After a temporary position at the IBM Thomas J. Watson Research Center, she joined the Connecticut faculty in 1989. Other scientist of statistics department. Will Coxon is a biochemist who studied pesticides, non-parametric equivalent of two samples test. Krushkalis and Wallace are economists who developed the non-parametric equivalent of the ANOVA. Spearman is a psychologist who developed a non-parametric equivalent of the correlation coefficient. Kendall is a statistician who developed another non-parametric equivalent, the correlation coefficient. Tukey is a statistician who developed multiple comparisons procedure. Dunnett is a biochemist who studied pesticides, developed multiple comparisons procedure for control groups. Kuls is an agronomist who developed multiple comparisons procedure. Computer technology provided many advantages over calculations by hand or by calculator, stimulated the growth of investigation into new techniques. Types of statistics. The study of statistics is grouped into two main categories. They include descriptive and inferential statistics. Descriptive statistics. Descriptive statistics describe the basic features of a population and how the data is organized. This enables analysts to see the characteristics of data and make sense of that data. There are two main types of descriptive statistics that scientists use, and they include A. Measures of central tendency. Central tendency measures comprise the mean, median, and mode. They are used to show the general trends with the data. B. Measures of spread. Measures of spread show how similar or different a set of values are and how they relate to each other. 2. Inferential statistics. Inferential statistics use complex mathematical computations to infer trends about a large population. When analyzing a large population, it is difficult to analyze each member of that population one by one. The two main classifications of inferential statistics comprise the following. A. Confidence interval. The confidence interval is calculated from the statistics of observed data that may contain the actual value of an unknown population parameter. B. Hypothesis testing. Hypothesis testing occurs when scientists analyze a sample of a population and then use that information to make a claim about the large population where the sample belongs to. Properties of statistics. Some of the potential characteristics that a statistic should include. 1. Completeness. Completeness of data is necessary to ensure the accuracy of the observed data. 2. Consistency. Consistency is viewed in terms of the uniformity or stability of data. Some of the statistics used to measure consistency include standard deviation, range, and variance. 3. Sufficiency. A statistic is considered sufficient if there is no other statistic that can be computed from the sample. Conclusion. Statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. In applying statistics to a scientific, industrial, or social problem, it is conventional to begin with a statistical population or a statistical model to be studied. Populations can be diverse groups of people or objects such as all people living in a country or every atom composing a crystal. Statistics deals with every aspect of data, including the planning of data collection in terms of the design of surveys and experiments. When census data cannot be collected, statisticians collect data by developing specific experiment designs and survey samples. Representative sampling assures that inferences and conclusions can reasonably extend from the sample to the population as a whole. Thank you for watching my activity. Introduction to myself. Name: Sakshi Kadam. Class: FYBSc, CS. Division: F. Roll number: FF63.